So good afternoon, everybody. I'm Ilaria Zorzi, a PhD student at the University of Florence. And together with my colleague Saverio Francini, we are going to present our work with the title In Situ, Tree Talker and Remotely Sensed Multispectral Imagery, Integration for Continuous Forest Monitoring, the first step towards wall-to-wall mapping of tree functional traits. First of all, I would like to introduce what is the Tree Talker device. The Tree Talker is, as I said, a device that measures simultaneously and with an hour detail environmental and plant variables, such as tree radial growth with this needle you see at the upper part of the picture, sap flow and silent moisture content with the two other needles you see on the right. With a spectrometer that is not visible, unfortunately, from this picture, the Tree Talker can register light penetration through the canopy and its spectral components. There is also an oscillometer inside that measures tree stability. And we are measuring environmental variables, as I said, such as relative humidity and air temperature. The Tree Talker are installed in two sites in Italy, in Tuscany. One side is silver fir pure stand, and we have 20 monitored trees there in the Vallombrosa forest, while other 20 trees monitored are in the Unione dei Comuni Valdarno e Val di Sieve in the Sant'Antonio forest, and here we are monitoring Fagus sylvatica. Actually, we have right now a paper under review in ecological informatics because we made an air package because the Tree Talker sends remotely all the data to a computer server. So we don't need to go to the forest to see what is happening there. But of course, in order to easy check what is happening to our plants and what is happening to our devices, we can remotely check with this package that is available on GitHub what is actually happening and solve the issues if there are any.
Hi all, I'm Saverio Francini, PhD student from the University of Viterbo and the University of Molise, but I'm working in the University of Florence in the GeoLab together with Professor Chirici. So as Ilaria said, Tree Talkers are great tools, but actually installation is very time consuming and they allow to register information just for some trees, while in a context of climate change, monitoring the health status of trees over large areas is required. So here we are testing if it is possible to link Sentinel-2 imagery with the multispectral data that is registered under the canopy by the Tree Talkers. So the idea is to try to construct a model. We acquired Sentinel-2 imagery over this period, over the two study areas we talked about, and we collected 23 images. So the first thing to think about is that Sentinel-2 acquires an image per day. I mean, one image every 3 or 5 days, while Tree Talkers acquire data every hour. So we calculate for the Tree Talkers the median of the Tree Talkers acquisitions over a time window of 5 hours. As a result, we obtained this data set. So for each tree, for each sensor, we have the timestamp, we have the image we selected, and then we have here the Sentinel-2 bands, and here the 12 bands that are registered by the Tree Talkers. As a first step, we try to see if a correlation between Sentinel-2 bands and Tree Talkers bands exists. And we found that the correlation was very low. So as you can see in this table, we were able to compare the blue band with the 8 band of Tree Talkers, then the green band with the band 10 of Tree Talkers, and so on. And as you can see here, the correlation was very low. This is because they are different sensors and we are registering information below and above canopy. So we defined, we constructed this model. It is a deep neural network model. So here we have as input all Sentinel-2 bands, and the aim is to predict as output all bands registered by the tree talker. This is the structure of our model. And yeah, we divided our data into 60% for training, 20% for validation, and 20% for testing. So the results that we are going to show you are for just this 20% of independent data. And as you can see, we obtained actually good results. So we predicted, for example, the first band using just the first band of tree talkers registered above the canopy using just, sorry, below the canopy using just Sentinel-2 data, actually using all bands registered by Sentinel-2. And here you can see that the prediction and the real values are very similar. The correlation was very large, and also the correlation was large, also calculated for single species, so for Abies alba and Fagus sylvatica. These results are good actually for all bands. Interesting thing is that some bands, for example, band 4 and band 5, were very good to separate between Abies and Fagus sylvatica. So first results suggest that this procedure may be implemented to obtain wall-to-wall maps of below canopy data. First steps actually now are to try to create, to test if exists a link between the below canopy registered by tree talkers and the tree functional traits registered by tree talkers. So this is the first step. If we will be able to do it, actually wall-to-wall mapping of tree functional traits, or for example, forest health status, will be possible. So me and Ilaria, thank you for the attention.